questions, some interesting questions to boost our confidence and knowledge in roots of polynomials. Please, this is STEM Cafe, make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. And I'd rather you subscribe so that anytime we have any video drop, you'll be among the first to get to know. And please comment, like, do everything to assist, please, and encourage others to join the channel. Share as well. Thank you very much. Now, we have this equation. We are so used to it, and that's why I'm using it. When you are using this root of polynomials to solve questions like this, you don't really need to know the roots. You don't really need to know it. That's why we are using the sum and products and some manipulation of some things you can get from the polynomials already to solve the problem. Most times we avoid getting the roots themselves rather. Now we have this x squared minus 5x plus 6 equals 0. You know the roots. That's why I'm using it. And the roots are alpha and beta. Quadratic. Now we have to find alpha cube plus beta cube. Equations with roots alpha cube and beta cube. That is S3. And this one is S3. And you have to find alpha raised to power 6 plus beta raised to power 6. During the course of this class, we talked about summation, recurrence, and substitution in solving the problems. So I will try to use as many as possible to illustrate solution to this problem. Now let's go. When you have a equation like this, we know what our alpha plus beta is. Will be equal to minus 5 over 1. That is 5. Alpha beta will be equal to 6 over 1. That's 6. That's the product. We know to find alpha plus beta. Alpha cube plus beta cube. This. We refer to it as summation alpha cube. Is going to be equal to summation alpha all cube minus 3 summation alpha beta. This is using summation. Please. This is using summation. Then we know what our summation alpha is. This is summation alpha. This is summation alpha beta. And that's going to give us, this is cube. So this is going to give us 5 raised to power 3 minus 3 into 5 into 6. I can easily factorize. And that's going to give me 5 into 25 minus 18, which is 5 times 7. And that's 5. So alpha cube plus beta cube is equal to 35. And we also refer to this as S3. Remember. So from here, I can easily do something. Form this equation with roots alpha cube and beta cube. I have known the sum. So what is alpha cube, beta cube? It's going to be alpha beta or cube. And that is 6 raised to the power 3. I believe that's 216. You see? So the new equation is going to be x squared minus 35x plus 260. So this is the equation with alpha cube and beta cube as roots. Equation with alpha cube and beta cube as roots. Then we have to find alpha raised to power 6 plus beta raised to power 6. Alpha raised to power 6 plus beta raised to power 6. And what does that mean? It is going to be the square for this. The sum of the squares for this. That is summation alpha cube squared. I believe you understand what I mean. We have for summation to solve summation alpha squared. This way, here, we have alpha cube, beta cube, as the root. So if we find the sum of the squares of the root of this equation, it's going to give us this. That's what I'm saying. Now let's see. Very interesting. Very interesting. So this is going to be, what is this? Minus 35, minus 35 over 1, that's 35 squared. Minus 2 into 2 and 6. That's what the answer will be. That gives me 7, 9, 3. So from this, we realize that alpha cube plus beta cube is equal to 35. The equation with the root alpha cube and beta cube is equal to x squared minus 35x plus 2 and 6. So alpha raised to power 6 plus beta raised to power 6 is equal to 7, 9, 3. We can confirm. We can confirm. So what do we have here? This is S3 and this is S6. So you can see, just little, practice to give you easy understanding of this. Let's see another way we can do this. Now let's use recurrence to see. If we use recurrence, it is almost the same thing as using summation. But let's see. If we are going to have it like this, x squared minus 5x plus 6 equals 0. Now let's multiply with x again. So we are going to have x cubed minus 5x squared plus 6x is equal to 1. Now assuming we are adding the roots, we are going to have alpha cube, beta cube. You understand? Okay. Let me try to see how I can make it easier. Here we are going to have alpha cube minus 5 alpha squared plus 6 alpha. Beta cube minus 5 beta cube squared plus 6 beta is equal to 0. So if I add this and this, I'm going to have S3 minus 5 S2 plus 6 S1 equals 0. I'm adding this and this. In this instance, there is no constants. So it's easy to handle now. What is our S1? It's equal to 5. S2 is going to be 5 squared minus 2 times 6. And what does that give? 25 minus 12, that's 30. So from this I can easily find S3. So S3 will equal to S3 minus 5 into 13 plus 6 into 5 is equal to 0. So I can see S3 minus 5 into 13 minus 6 is equal to 0. So S3 minus 35. So S3 is equal to 35. You can see that this one corresponds to the answer we got previously. That is S3. And we also know that the product is going to be alpha beta all cube, which is 6 cube. That's 2 and 6. So from this is the sum, this is the product. We can easily form our equation. And that's going to be x squared minus 35x plus 2 and 6 equals 0. And now, we can easily do what we did the other time. To find the squares of this. To find, so that we can get alpha raised to power 6 plus beta raised to power 6. And that's going to be the sum of the squares of the roots of this equation. The sum of the square of the roots of this equation. This one is for alpha cube and beta cube. Now, all you need to do is to say equal to 35 squared minus 2 into 2 plus 6. So, 793. Just as before. That is it, straight away. Now let's look at the last method, which is substitution. This one is recurrence. Now let's look at this. We have x squared minus 5x plus 6 equals 0. And we are going to form another equation with alpha cube and beta cube. So we can now say y equal to x cubed. Therefore, x is equal to y raised to power 1 over 3. We can either, okay, we can just make it like this. X squared minus 5x is equal to minus 6. We can expand like this straight, or we bring this one into this place. If we expand like this straight, we can now be taking this into this equation. But I like substituting this already in the equation before expanding. What I mean is this. This one is now going to give me, I'm going to substitute y raised to power 1 over 3 for x here. So I do it like this. Y raised to power 2 over 3 minus 5 y to the power 1 over 3 is equal to minus 6. Please take note of this equation. Now, I will cube this equation. And that's going to give me y raised to power 2 minus 3 into y raised to power 2 over 3 squared times minus 5y raised to power 1 over 3 plus 3 into y raised to power 2 over 3 into minus 5 raised to power y squared minus 125y is equal to minus 6 cubed. So let me put it like this. Minus 216. So what do I have next? I have y squared, this one, and this. So this is y raised to power 4 over. This is 15 minus 15. Y raised to power 4 over 3 times 1 over 3. That's y raised to power 5 over 3. This one is going to be, okay, this one is squared, plus 3 times 25, that is 75. Y raised to power 2 over 3 times y raised to power 2 over 3, that is y raised to power 4 over 3. Minus 125y is equal to minus 216. Please understand this expansion. That's just really working. At last, I can now say y squared minus 125y. Let me factorize this. If you look at this, y raised to power, okay. If you look at this, I can bring out 15y out of it. So I'm going to have minus 15y into y raised to power 2 over 3 minus 5y. This is 1 raised to power 1 over 3 is equal to minus 216. And if you look at this and this, they are the same thing. This equation and this equation are the same thing. Y raised to power 2 over 3 minus 5y raised to power 1 over 3 is the same thing. So we can conveniently substitute minus 6 for y raised to power 2 over 3 minus 5y raised to power 1 over 3 here. So we can now say y squared minus 125y. Since you can put minus 6 here, minus 6 times minus 15, that is plus 90. So that is plus 90y is equal to minus 2.6. So you can see this one is also very easy. The only thing is get your expansion at this stage. That is all. So we can work it out from here. So from here, I can now say y squared minus 125 plus 90, that is minus 35, minus 35y plus 216 equals 0. So this is the new equation with alpha cube, beta cube as the roots. In this instance, I'm using substitution. Now to find summation alpha is equal to 6, I can easily say it's going to be square of this. 35 squared minus what's it called? Minus 2 into 216. We have gotten this. This is the easiest way. You can see we have used the 3 techniques. We have it's possible. So with practice, you know which one is good for you or is you are easily adaptable to. And anytime any question comes, you will know from your practice how to tackle it. Let's go to another question. Now look at this. It says if x is going to be is equal to minus 2 plus p. This is equal to 2 plus p. Product of root is equal to 7 plus 2. I'm also giving another information that the roots differ by 1. So the roots are alpha and alpha plus 1. Now, it means that alpha plus 1 is equal to 2 plus p. So we have 2 alpha is equal to p plus 1. 2 alpha is equal to p plus 1. I said I also know that. So it means that alpha is equal to p plus 1 over 2. And alpha plus 1 is equal to p plus 1 plus over 2 plus 1, which is p plus 1 plus 2 over 2. And that is equal to p plus 3 over 2. So from this, we can now substitute this into the product. That is when we have it like this. Alpha into alpha plus 1 is equal to 7 plus 2. 7 plus p. Yeah. And that means alpha is p plus 1 over 2. Alpha plus 1 is p plus 3 over 2. We are told that it's equal to 7 plus p. So we can now multiply. So it's going to be p squared plus 4p plus 3 is equal to 28 plus 4. Now, subtract 4p from both sides and 3 from both sides. We are going to have p squared is equal to 25. So p is equal to plus or minus 5. And we are told that p is greater than 0. Since p is greater than 0, p is equal to 5. So you can see, that's another way of using the knowledge we got it. The quadratic equation has roots alpha and beta. Given that 1 over alpha plus 1 over beta equals to half, and alpha squared plus beta squared equals 12. Find 2 possible quadratic equations that satisfy these values. Now we are given this 1 over alpha plus 1 over beta, which is equal to alpha plus beta over alpha beta is equal to half. So from this you can easily say 2 alpha plus beta is equal to alpha beta. Let's take this as 1. 2 of this is equal to this. We are also told that alpha squared plus beta squared, and which we also know to be equal to alpha plus beta all squared minus 2 alpha beta is equal to 12. So we can easily now say alpha plus beta all squared minus, alpha, 2 into 2 alpha plus beta is equal to 12. We can now say that alpha plus beta all squared minus 4 into alpha plus beta is equal to 12. So from this, we can easily say alpha plus beta is equal to z. Therefore, z squared minus 4z minus 12 is equal to 0. Okay, is equal to 0. So I can now say z squared minus 6z plus 2z minus 12 is equal to 0. So I can say z minus 6 plus 2 into z minus 6 is equal to 0. So z equals to 6 or minus 2. Now if z, that is, we have now discovered that alpha plus beta is equal to 6 or minus 2. And we know the relationship between alpha plus beta and alpha beta. So alpha beta is equal to 2 times this is equal to 12 or minus 4. Therefore, a possible quadratic equation are x minus 6x plus 12 equals 0, or x plus 2x minus 4 equals 0. So those are the 2 possible quadratic equations. Now we have x cubed plus 3x squared minus 7x plus 2 equals 0. And we have to find x2, that is alpha squared plus beta squared plus gamma squared. We know the formula, summation x squared, is applicable here also. Summation x, summation alpha, summation alpha all squared minus 2 summation alpha beta. Summation alpha here is equal to minus 3. Summation alpha beta is equal to minus 7 over 1. That's minus 3 over 1. Therefore, summation alpha squared is equal to minus 3 squared minus 2 into minus 7. And this is 9 plus 14. That's 10. Now let's try to use recurrence to find the answers of this question. So we have x cubed plus 3x squared minus 7x plus 1. Now let's divide 2 by x. We are going to have x squared plus 3x minus 7 plus 2 x raised to the power minus 1 equals 0. Now if we are using recurrence, we are going to have something like this: x2 plus 3x1 minus 21 plus 2x minus 1 equals 0. And from our previous lecture, we have realized that x1 is equal to coefficient of x squared over x cubed multiplied by minus 1. That's going to be minus into 3 over 1, which is minus 3. S minus 1 is equal to minus coefficient of x over the constant. That is minus 7 over 2, which is 7 over 2. Now let's substitute this into this equation here. So you are going to have x2 plus 3 into minus 3 minus 21 plus 2 into 7 over 2. So this cancels this. So you are going to have x2 minus 9 minus 21 plus 7, which gives us 0. No, this is minus 30 minus 23. So x2 minus 23 equals 0. So x2 is equal to 23. So you can see it's the same thing with this. So summation alpha squared is equal to 23. So this is if you use summation, and this is if you use recurrence. You can also use substitution. You can also use substitution to get it. Let's see how that can be done. This substitution is not necessary, but assuming, just to help us practice substitution, let's see what we can do. We can now say that since x cubed plus 3x squared minus 7x plus 2 equals 0. So we can now say that let's say y equals to x squared. So y, x equals to y raised to the power half. We can now say y raised to the power 3 over 2 plus 3y minus 7y raised to the power half plus 2 equals 0. Now let's rearrange. So we can say y raised to the power 3 over 2 minus 7y raised to the power half is equal to minus 3y minus 2. Let's square throughout. So this is going to give us y raised to the power 3 plus 49y minus 2 into 7y raised to the power half into y raised to the power 3 over 2. That's going to give us 9y squared plus 4 minus 2 into minus 3y minus 2. So from this we can say y cubed plus 49y minus 14. Y raised to the power half and this is going to give us y squared will be equal to 9y squared plus 4 minus 2 minus 2, that is 4, minus 12y. Now let's put everything to one side. So we are going to have y cubed minus 14y squared minus 9, that's minus 23y squared. 49 plus 12, that is 61y minus 4 equals 0. So this is equation with alpha squared, beta squared, and gamma squared as roots. This is it. So from this, you can easily say summation alpha squared, that is alpha squared plus beta squared plus gamma squared is equal to minus 23 over 1. That's 23. So you can see it is fun. Just know your way around all these things.